In this lesson, we'll be evaluating trigonometric expressions. So if I have a trigonometric expression like sine of 30 that's a part of a bigger expression, we're going to evaluate the trig function first, or the trig value first, and then follow order of operations. Example 1a, we need to find the sine of 30 and then multiply that by 10 and add 7. Recall our angle markers, 0, 90, 180, 270, and 360 for the axes. And so a 30-degree angle will be in quadrant 1. So here's a 30-degree reference triangle, and the smallest side is 1, which is across from the 30-degree angle, and the next largest side is the square root of 3, which is across from the 60-degree angle, and the hypotenuse is 2. Since this angle terminates in quadrant 1, all of the adjacent and opposite sides are positively signed. So the sine of 30 degrees is opposite over hypotenuse, or 1/2. Now we just need to follow order of operations. And evaluate. So that expression has a value of 12. In B, we just need to find the cosine of 45 degrees and then multiply it by 6 and subtract that from 3. 45 degrees is also an angle that terminates in the first quadrant, so we can fill in our sides, all of which will be positive. So the cosine of 45 degrees is 1 over the square root of 2, or the adjacent over the hypotenuse. That will need to be rationalized as square root of 2 over 2. After replacing cosine of 45 with that value, we need to multiply by 6. And since one term is multiplied by a radical, they are unlike terms and cannot be combined. In C, we'll need to find the value of tangent of 135 degrees. We can draw axes and recognize that 135-degree angle terminates in the second quadrant, with a corresponding reference angle of 45 degrees, since 135 plus 45 is 180. Using a basic 45 right triangle, we can put the side lengths in, but we'll need to take care that the horizontal side, or the adjacent side, will be negative in quadrant 2, since x is negative in quadrant 2. Tangent of 135 is opposite over adjacent, which is 1 over negative 1, applies to negative 1. Replacing tangent of 135 with negative 1, we just now need to do the arithmetic. 4 plus 6 times negative 1, multiplying first and then subtracting. In D, we have something that looks a little bit more complicated because now we have a radical expression. To draw a 330-degree angle, which terminates in quadrant 3. 330 degrees is only 30 degrees shy of 360. So our reference angle is 30 degrees. 30, 60, 90 reference triangle, we need to take care to recognize that the opposite side this time, since it's hanging down, is going to be a negative value. So the tangent of 330 is opposite over adjacent, which should be rationalized as negative square root of 3 over 3. After replacing tangent 330 degrees with that value, we need to multiply and add the like radical terms. In E, we'll need to find cosine of 180 in order to evaluate this expression. 180 degrees is a quadrantal angle, meaning it falls in between quadrants, so we'll need to use the circular definition to find the cosine. Recall that the coordinates of the point on the terminal side, negative 1, 0. Remember, the negative 1 is not important as long as it's negative, so I'm just picking negative 1 as a value that we can use. That A is the adjacent side and B is the opposite side. And C, the value of the hypotenuse, can be found using the Pythagorean theorem. So C's value is positive 1. So when we're finding the cosine, we need to find the adjacent over the hypotenuse. which is -1/1, or just -1. Replacing cosine of 180 with -1, we now need to just do the arithmetic, multiplying first, and then adding. In f, we'll need to find the tangent of 360, which is another quadrantal value. We can use any value that's positive for the x-coordinate, and then 0 will be the y-coordinate. Remember, those are our adjacent and opposite sides. C can be found using the Pythagorean theorem, and this value will again give us 1. So tangent of 360 equals the opposite over the adjacent, which is 0/1, or 0. Replacing tangent of 360 with this value, we now just need to do the arithmetic, multiplying first and then adding. Try A below on your own. Here's the answer to the try this. Now try B. And there's the answer to B. Notice that this one is a quadrantal angle, so we'll need to use the circular definitions. But you can always think of the x value of your point as the adjacent side and the y value as the opposite side. On this page, we are introduced to a notation for raising a trig function to an exponent. When you have a trig function that's raised to an exponent, we would put parentheses around it and raise that entire trig function to the exponent. But the short notation for that is, instead of saying sine of theta squared, we'll say sine squared of theta. So in example 2a, we have to find the square of tangent 30. So now we just need to fill in the value of tangent 30. We can draw a reference triangle in the first quadrant, label the sides, and then evaluate the tangent, opposite, over adjacent. Since we're going to square this, there's no need to rationalize the denominator. Using order of operations, the exponent needs to be applied first, then multiplication, and then addition. We'll need to find the sine of 210 degrees before we cube it. 210 can be thought of as 180 degrees plus an extra 30 degrees, which will give us a 30-degree reference triangle. Since this angle terminates in quadrant 3, both opposite and adjacent sides are negative. Now let's evaluate the sine of 210, which is the opposite, over the hypotenuse. Exponents need to be applied first, followed by multiplication, addition. To evaluate the next expression, we'll need to find sine of 270 degrees first, before squaring it and then performing other operations. 270 is a quadrantal angle. The point of its terminal side can be the point 0, -1. Again, the -1 doesn't matter as long as it's some negative value. The first coordinate has to be 0. For quadrantal angles, the C value, or hypotenuse, is the absolute value of the non-zero coordinate. Sine of 270 is opposite over hypotenuse, which is just -1. Squaring, then multiplying, and finally adding brings us to the value of the expression. Try the first example below on your own. The value of this expression is 0. Remember that a 240-degree angle is 180 plus 60, so that gives us a 60-degree reference angle in the third quadrant. Try B now. Here's the value of this expression. If you were wondering how to cube a radical, remember that cubing is just multiplying the same factor 3 times. Multiply the first two together by the third factor, gives you the value of -√3 cubed. All right, just a quick review of the circular definitions of sine, cosine, and tangent. Remember that A, or the x-coordinate, will always be the adjacent side, and B, or the y-coordinate, will always be the value of the opposite side. So the opposite side will always be vertical like a y-coordinate. Sine of theta equals opposite over hypotenuse, and cosine of theta equals adjacent over hypotenuse. Tangent is opposite over adjacent, and C is the length of the hypotenuse given legs of A and B. Let's review what the value of sine, cosine, and tangent are in each of the quadrants in terms of being negative or positive. In quadrant 1, A and B are both positive, and C is always positive, so sine is positive. That second function should be cosine, which will also be positive, and the third function should be tangent of theta, which is also positive. As we rotate into quadrant 2, the x-coordinate becomes negative, which corresponds to A. So A is negative, and the other two parameters are both positive. Since sine of theta is b over c, it remains positive. Cosine of theta is a over c, which will be negative, and tangent of theta is b over a, which will be negative. In quadrant 3, a and b are both negative, while c is always positive. Sine of theta is b over c, which will be negative. Cosine of theta is a over c, which will be negative. And tangent of theta is b over a, which is a negative over a negative, so tangent of theta will be positive. In quadrant 4, a and c are positive, is negative. Since sine of theta is b over c, its value will be negative. Cosine of theta is a over c, so its value will be positive. And tangent of theta is b over a, so its value will be negative. Does this seem like a lot to keep in mind? Probably. There's a really good way to remember all of this. So if you look below at the circle, and we'll label the quadrants in order, all art, Trig classes helps us label the quadrants in order. Remember, that's the same order. The order of the quadrants is the same as the order in which angles rotate around the circle, 0 degrees to 90 degrees being in the first quadrant. Now I'm going to fill in letters after A, S, and TC. All ratios are positive in the first quadrant. Sine only is positive in the second quadrant. Tangent only is positive in the third quadrant. Tested, cosine only is positive in the fourth quadrant. So ASTC can help you remember which functions are positive in which quadrants. So you can remember all smart trig classes. Some classes also memorize Andrew sells trash cans. All students take calculus, which I'm not sure I like that one because it's not really true. And a last one, how I learned at Albany State Teachers College. Whichever one you prefer is what you should use. When solving a trig equation for an angle theta, we cannot use inverse trig functions, that is sine inverse, cosine inverse, and tangent inverse, because they only give one of the solutions. To solve a trigonometric equation, we're going to draw reference triangles in the correct quadrants based on whether the trig ratio is positive or negative, and then find the angle. In example 1, we're trying to solve the equation sine of theta equals -1/2 for angles between 0 and 360. Since sine is negative, we know we will not use quadrants 1 and 2, in which all trig ratios are positive and sine is positive. So we'll draw reference triangles in quadrants 3 and 4, label the sides based on the fact that sine is opposite over hypotenuse, and use Pythagorean theorem if you want to find the value of the third side, which is not necessary, but you can, before we recognize this as a 30, 60, 90 triangle. 30 degrees would be the reference angle since it's opposite the smallest side of the triangle. In quadrant 3, the angle is 180 degrees plus an additional 30 degrees, which gives us an angle of 210. To find the quadrant 4 angle, we can rotate 270 degrees plus an extra 60 degrees, which gives us an angle of 330 degrees. Another way to recognize this one is to know that we're just 30 degrees shy of a full revolution, or 360. And we've just found the two solutions to this equation. In example 2, we're trying to solve the equation cosine of theta equals -1. It may be helpful to think of this as -1/1, which is adjacent over hypotenuse, or a over c. So our horizontal coordinate needs to be -1, and our hypotenuse needs to be 1, and I hope you'll recognize this as a quadrantal angle. Since the adjacent side is negative, that's going to mean that this terminates on the left side of the coordinate plane. That terminal side represents a 180 degree angle. So 180 is the only solution on the interval from 0 to 360 for this particular equation. In example 3, we're going to solve for theta if tangent of theta equals the square root of 3 over 3. It may help to think of this trig ratio in unrationalized form, 1 over the square root of 3. And remember that if a trig ratio is positive, its numerator and denominator could also both be negative. It should give us a picture of a reference triangle in quadrant 1, where all functions are positive, and also quadrant 3, where only tangent is positive. Labeling opposite over adjacent, we can recognize a 30, 60, 90 triangle with a hypotenuse of 2 and a reference angle 30 degrees. In quadrant 3, both opposite and adjacent sides are negative, and the reference angle is also 30. So our quadrant 1 angle is the same as the reference angle. The quadrant 3 angle found by rotating 180 degrees and then an additional 30 degrees, angle value of 210. So there is our solution set. All right, try the last example on your own. Here's the answer for example 1. And hopefully you realized that it was easier to use the unrationalized version of cosine. And since cosine is negative, we're going to find quadrant 2 and 3 angles of 135 degrees and 225 degrees, which are both 45 degree reference angle. All right, try this on your own. All right, hopefully you recognize this one as a quadrantal angle, since our opposite side is 0 and hypotenuse is 1. That means that the adjacent side can either be positive or negative, so that's going to be on the positive x-axis or on the negative x-axis. That'll give us angles of either 0 or 180. Note that we're not including 360, since the inequality stated in the problem does not include 360 as a possible solution. That's it for the lesson, and that's it for the unit.